Hello students of science. In this video we're going to talk about using chemical formulas. We've been previously talking about the elements. Now we're going to talk about what you can do with those formulas when they're all put together. First thing we need to talk about is formula mass. Formula mass is the sum of the average atomic masses of all atoms in a formula. If you recall, the average atomic mass, that's taken directly from the periodic table. So each entry in my periodic table, here's the atomic number, there's the atomic symbol, but we are talking about the atomic mass here. That's what's at stake here. So let's take a look at my first example here of water. Water is going to be a combination of obviously hydrogen and oxygen. And what I'm going to be doing is I'm going to be summing together the average atomic masses for all the atoms in a formula. So let's look at water there. Hydrogen is going to be 1.01. I'm going to be rounding that there to the hundredths. Oxygen is going to be 16.0. I'm going to round that 15.99. And if I do 2 of hydrogen, 2 times 1.01 plus 1 times 16, so that's going to give me a total formula mass for water of 18.02 atomic mass units. Now, we also need to clarify, molar mass and formula mass are going to be numerically identical, and I'm going to be using those pretty much interchangeably, as do most chemistry teachers. So as I just mentioned, the formula mass of water is 18.02 atomic mass units, and we would talk about 1 mole of water is going to be 18.02 grams. You'll notice those numbers numerically the same. We're going to use those terms practically interchangeably. So molar mass. It's handy because it allows you to convert between both grams and moles in your formula. So let's take a look how many grams of water are in 8.5 moles. Well, here I've previously calculated the molar mass of water, so I'm going to take 8.5 moles and multiply it by 18.02 grams per mole, which is the molar mass right there, and that's going to work out to be 153.17 grams. So just this, multiplied by that, the moles are going to cancel out and I'm left with grams. Or I could go the opposite. How many moles of water are in 79.09 grams? Well, I'm going to take 79 grams and divide that by 18.02 grams per mole, and the grams are going to cancel out, and I'm going to be left with 4.39 moles. We'll do some practice on that, but you see, it's a very simple process here, just multiplying it by this gram molecular mass. Now, percent composition is how we can figure out how much of each element there is in my particular compound. So we'd say the percent composition is the percentage by mass of each element in a compound. So let's look at water, which I've been using before. Hydrogen, it's going to be 1.01 for each atom of hydrogen, and there's 2 of them, so the total amount is going to be 2.02 atomic mass units. Oxygen, there's only 1, so it's 16 times 1 gives you 16. So the total molar mass is going to be 18.02 units. These sum together. Now, when I want to figure out percent composition, I'm going to take the mass of the elements in 1 mole of compound and divide it by the total molar mass of the compound and multiply it by 100 because I'm trying to go for percentage. So let's look at hydrogen. Hydrogen is 2.02 atomic mass units, but the total amount for water is 18.02. So I take 2.02 divided by my total molar mass, 18.02, and multiply it by 100, and we can say that hydrogen makes up 11.21% of water. Oxygen, same idea. 16 divided by 18.02 times 100 is going to give me 88.79%. The percentages should all add up to 100%. So my hydrogen percentage plus my oxygen actually works out to be 100% even. So we can say that we have all of the elements of a first-class thrower, our composition, and you can see right here, this is percent makeup of something. By the way, all of that adds up to 100%, as everything should. So analytical chemists in the Wild West, they're not talking about filling you full of lead because it's 98% lead, but there's also antimony and silver and nickel and cobalt. You get the idea there. Percent composition, very important for when we're going to be trying to figure out more about the chemical formulas.